Number 1, what is the solution of negative 3 times 2x minus 5 plus 1 is greater than or equal to 4? So what is the solution of that problem? And graph on a number line. So a couple of things I want you to notice. First off, remember, an inequality is just an equation. It just has a fancy equal sign. So instead of an equal sign, there is an inequality. So remember, the only rule when solving an inequality or getting it into y equals mx plus b form is if you multiply or divide by a negative number, you have to change the sign of the inequality. Alright, so now let's go ahead and it says what's the solution? That means solve. So once again, notice, isn't it linear, meaning degree 1? Aren't all the variables degree 1? Okay, so let's solve. Now there's many different ways we can do this. So I have negative 3 times 2x minus 5 plus 1. What I'm going to do is greater than or equal to 4. I'm going to solve it algebraically in this way. Now there's other ways of doing it. I'm going to subtract 1 from both sides. So I have negative 3 times 2x minus 5, and then we have is greater than or equal to 3. Now we did not need to change the inequality. We added a negative, we subtracted a number. That does not qualify to change the inequality. Now you could either distribute this 3 in, which I'm not going to choose to do. I'm going to divide both sides by negative 3. Now, didn't I just divide by a negative? Yeah? So you guys should be doing this work. So this divides out and becomes 1. So on the left I have 2x minus 5 is, I change the inequality, I divided by a negative is, it's less than or equal to negative 1. 3 divided by negative 3 is negative 1. And now it's just algebra solving for x. Questions up to here, so I add 5. So I have 2x is less than or equal to 4. So I divide both sides by 2. So we have x is less than or equal to 2. So there's our solution. X values less than or equal to 2. So there's actually multiple solutions. It's all x values that are less than or equal to that. So we graph it on a number line. So I draw my number line. So it doesn't really matter. 0, 1, 2. So x values, x is left and right, x values less than or equal to 2. So it includes 2, and the x values that are less than that would point this way. So that's really how we would show our solutions, because there's multiple solutions. All of those x values will work. Does everybody understand that? Okay, next problem. You're writing these down, right? You all understand that it is a requirement. Okay. Next problem. Okay. So number 2 and number 3, it says, what is the, is the inequality always, sometimes, or never true? So I'll give you a second to get those done. Okay, so let's go ahead and solve it, okay? So we'll multiply in negative 2, so we have negative 6x minus 2 is greater than negative 6x plus 7. Now we didn't need to change the inequality because we didn't multiply a negative to both sides of the equation. We just multiplied in our negative, so we're good. So let's continue to solve. So I'm going to combine my x's. So I'm going to add 6x to both sides. So we have negative 2, that becomes 0. So we have negative 2 is greater than, and then that also happened to become 0. So we have 7. Is negative 2 ever greater than 7? No, so the answer would be this is never true. Questions? Okay, let's solve the next one. So I'm going to go ahead and multiply in again that 5. So we have 10x minus 15 minus 7x, so distributed, and then is less than or equal to 3x plus 8. So we're going to solve to see, or simplify this down to see if it's always, sometimes, or never. So I'm going to combine my x's on the left, so that would be 3x, because 10x minus 7x is 3x. 3x minus 15 is less than or equal to 3x plus 8. Okay, so continuing to solve, we'll combine our x's algebraically, subtract 3x, subtract 3x. So 0, so we have negative 15 is less than or equal to 0 plus 8. So is 8 greater than or equal to negative 15 always? Yes, on a number line. Won't that always be greater than or equal to? Yes, so you'd say always. Questions? Okay. Next problem. It says solve and graph the compound inequality. So there's a difference between and versus or. Remember I told you a little scenario about the person who asks for Christmas presents and they say, I want a toy and I want a trip to Hawaii and, so they're picky. So they want it all. And so this is, and means intersection. Or means either or. So the person on Christmas that says, I want this or this or this. So they're not as picky. They'll take anything. Either or will work. So with that being said, let's graph this. So it says solve and graph the compound inequality. So first of all, we're going to solve for x. So we'd subtract 1. So we have 6 is less than 2x. We're going to graph and or, just so that we see the difference on this one. So then we divide by 2. Very carefully, some of you can't, you've got to really look at these carefully. So we have 3 is less than x. Some of you, when you switch these around, in fact, like a lot of you, mess it up. So isn't it eating the bigger thing? Yes. So it should be x is greater than 3. Does everybody understand? You cannot mess it up when you switch it around. In fact, many of you do, but you can't. So there's one of our solutions. Let's solve for x over here. So divide by 3. So we have x is less than or equal to 6. Okay. So we're going to graph and versus or on a number line. So we're going to do and first. So I'm going to draw my number line. So and is picky. It's the intersection of both. And is picky. It's the intersection of both. So where at the same time, so I'm going to draw my number line 0, 1, 2, 3, 4, 5, and 6. So this could keep going. Okay. So it says it's got to be x values greater than 3. So that would be starting from 3. So not equal to 3, greater than 3, that would be this way, right? This way. But then at the same time, less than, because it's and, less than or equal to 6. So, and at the same time. This is how you would graph and. Does everybody understand? It's the intersection of both answers at the same time. These are our answers, right? Does everybody understand and? So now what if it would have been or? Let's graph or now. So and versus or. Or either or gets to come. So we have our number line once again. 0, 1, 2, 3, 4, 5, and 6. So either or answer gets to come. So I'm going to graph this. So it says x value is greater than 3, not including. So that would be like this. All of those, right? Or x value is less than or equal to 6. So let's see here. Less than or equal to 6. Wouldn't that be all of these? So wouldn't that include 3? So that fills in that circle, right? So wouldn't that be all real numbers, guys? Yeah. Okay, so yeah, we drew on a number line. The answers are all real numbers. That one's all real numbers. Do you guys see the difference between and or? It's a huge difference. So and is the intersection, or is either or. Questions on that? Okay. So next one. We're getting there, guys. Stay with me. Says, describe in words. So I would just write this down on your problem number 5. Just write down this, and then you'll describe it, and you'll answer the problem. So I'll give you a second so that you can concentrate on what's being asked. Are you ready to answer? Okay, it says, describe in words the transformation of the parent from the parent function. Remember, parent function means the most basic non-shifted function. And then it says, what is the equation of the parent function? So, let's look at this. So it's f of x is equal to negative 1/2 times by the absolute value of x minus 3 plus 2. Absolute value functions, you guys, you've got to know this. An absolute value function is a sharp V. Do we all understand that? Okay. Shifting works the same for all functions. I personally like to start out with shifts left and right, up and down. Anything added with x in parentheses, because it's in parentheses or grouped with x, it's your shift left and right, go opposite, right? If we don't know this by now, we should be put back in secondary too. So are we going right 3? Guys? Right 3. So there we're describing the transformation, so we're going right 3. Then anything added on the outside of the function to the entire function in general will be your shift up and down, sign stays the same. So won't that be up 2? So we know we're going right 3 up 2. Now remember, if you have a negative in front of the entire function, which we do, a negative in front of, our a value is negative, That's a reflection over the x-axis. Is everybody comfortable with that? Okay, so that's a reflection over the x-axis because there's a negative. So it's a reflection, and you've got to be specific because we could reflect over y and it would look different. So reflection over x, axis, and then there's one more transformation here. Our a value is 1/2. If your a value is less than 1, it's a compression. If a is greater than 1, it's a stretch. Stretches it up. So our absolute value sign, guys, we have a 1/2. It's going to stretch it. Does everybody understand that it's less than 1? Now you don't look at the negative. The negative doesn't count because some people will say, well, -3 is less than 1, so it must be a compression. Wrong. You look at the absolute value. You don't look at the negative to determine if it's a stretch or compression. Does everybody understand how 1/2 will compress it? So we would say a compression of 1/2. We have described in words the transformation from the parent function. So the parent function is the most basic non-shifted function. So we're answering the second part. The parent function would be f of x is equal to the absolute value of x. Isn't that the most basic non-shifted function of an absolute value function? Okay, so we've done all the transformations. Questions on that? Okay, we're getting there. Okay, guys, this has been a long time ago, but we are advanced thinkers at this point in the year, so we should be able to do this pretty dang easy. And if it didn't make sense to you before, it should now. It says, what polynomial in standard form has these solutions? So my question is, how many solutions do we have? 2. So what degree should my polynomial be? 2, right? If it's degree 3, it has 3 solutions. If it's degree 4, it has 4 solutions. If it's degree 2, it has 2 solutions. So we have 2 solutions, it's degree 2. So if these are the solutions, don't we work backwards to find the polynomial in standard form? So remember, to find the solutions, we had linear factors set equal to 0. So we need to go backwards. So we're going to subtract 2. Subtract 2. So over here on the left, I have x minus 2 is equal to 0. Now, does everybody understand why that linear factor would give me the answer x equals 2? Yes or no? Because I can explain further. We all understand that if x is equal to 2 was our solution, x minus 2 must have been our linear factor, meaning degree 1 factor, okay? So then to make it 0 here, if x equals -1, then the linear factor that gave us that answer must have been x plus 1 is equal to 0. Once again, does everybody understand why x plus 1 would give us the solution x is equal to -1? Now remember, before we split them apart and individually have them set equal to 0, they were together and set equal to 0 being multiplied. So we have x minus 2 times x plus 1, and right there they were equal to 0. The zero product property rule was what allowed us to split them up and individually set them equal to 0, right? Okay, now remember this only works, guys, if this is equal to 0, because I've seen people get one on the stage that said x minus 2 times x plus 1 is equal to 1. Find the solutions, and they say 2 and -1, which is not true. You couldn't do it that, because it's not equal to 0. Do you all understand that? Okay, you have to multiply it out, combine like terms, get it equal to 0, solve by a quadratic formula. Okay, so this one, so now we're going backwards. This is what's the polynomial? Well, that is the polynomial, but I want it in standard form. So we would multiply it out. X squared plus 1x minus 2x minus 2 is equal to 0. Combine like terms. X squared minus x minus 2 is equal to 0. So guys, the polynomial that had these solutions was this quadratic. We worked backwards. Everybody comfortable with that? Awesome. So we would have done the same thing if we would have had another solution, x is equal to something. You do the same thing. Okay, we're almost done, promise. Okay, here we go. So just one more. It says, find the inverse of f of x is equal to 3 over x plus 2. So our algebra skills have got to be way up there, which, guys, my secondary 2 kids could do this problem like this, so I know you can do it. Finding the inverse, what do? Switch x and y. Isn't that how we always find an inverse? So we have x is equal to 3 over y plus 2. Now from here, let's be algebra junkies and let's be really smart. Don't we have to solve for y? But if we multiply both sides by 3, wouldn't that be a 9 on top? Making it worse, right? So we wouldn't multiply both sides by 3. Now to solve for y, won't we need it in the top? So I'm going to first of all say, okay, I know that x is x over 1, yeah? So now I have a fraction on the left, a fraction on the right. A fraction with nothing added, a fraction with nothing added to the fraction. So I'm going to flip both sides of the fraction. You can do that as long as you do it equally to both sides of the equation. So we have 1 over x is equal to y plus 2 over 3. Does everybody see how I literally took and flipped both sides of the equation? We can do that as long as we do it to both sides. If you do it to one side, you change the problem. Now from there, solve for y. So now, wouldn't it be appropriate to multiply by 3 because it's being divided by 3? Multiplication undoes division, so we multiply both sides by 3. Now you multiply fractions straight across, people. 3 times 1 on top is 3. 1 times x on bottom is x. Is everybody comfortable? So we have 3 over x is equal to 3 over 3 divides out and becomes a 1. That's why we did it. So then we have y plus 2. Our last step will be to subtract 2 from both sides. So, I'm going to make sure I write this correctly. So we have y is equal to, we have 3 over x minus 2. I'm going to put it in order. Now, we would write it as f inverse of x just because we would. That is what we found. That's like saying we found the inverse. The inverse function of f of x is 3 over x minus 2. Ding, 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 ding. Questions on that? Okay. All right. Sweet. So you're doing pages not 1 through 4. This was because I was going to do this the other day. It's pages today 5 through 9. Ready, set, go. Check them off with me and have me initial them as you go.